Hi, everyone, and welcome to my talk, which is all about the Arazzo specification. So, hopefully, some of you have already heard about the Arazzo specification, or perhaps the OpenAPI workflows specification, which was our working title for a little while. But this is a new specification that we have brought out under the umbrella of the OpenAPI initiative. Arazzo itself stands for tapestry in Italian, and it's all about giving us the ability to deterministically describe API workflows across the modern API stack. We're incredibly excited about this specification, and what I'm going to do over the next 25 minutes or so is take you through the specification and let you ponder if it's the missing piece of the API puzzle. So just a little bit about me. My name is Frank Kilkomins. I'm Principal API Technical Evangelist at Smartbear. I'm a developer and architect by trade, and I have a great passion for APIs. I do quite a bit of work also with the Open API initiative, and I'm one of the editors of the Arazzo specification. So when I talk about the Arazzo specification, well, what is it? How we have described it as part of the working group is it describes an approach to document use case orientated APIs in a programmatical readable format. And when I talk about a workflow, it's nothing more than a series of API calls, which when woven together, help us as developers accomplish some business objective or outcome. And the additional human readable nature of the spec, so the formats we're talking about are things like JSON and things like YAML, really enable us to improve the ability for us to tell the story of an API across the multiple calls that might be involved from a client and server perspective. The primary use cases that we covered as a working group are as follows. So, ultimately, we wanted to be able to ensure that we could deterministically describe the recipes for the use of APIs to achieve outcomes. So we've all been there in a situation where we've been onboarded into a developer portal and we've got access to the technical reference documentation. And unfortunately, this could be a really, really large open API document with tens or even hundreds of endpoints. It's quite hard for us to intuitively understand in what sequence we need to make calls in order to achieve our jobs to be done as a consumer. On other kind of ends of the spectrum, providers have done a good job with being a little bit more composable about how they approach the delivery of their APIs. But ultimately, from a consumer perspective, again, the business flow might span multiple open API descriptions. And again, we don't have any artifact currently allowing us to kind of tie them together in a meaningful manner. We've always also been in the situation where we've struggled with documentation accompanying the technical reference docs like OpenAPI getting out of sync. So ultimately, when we craft developer portals and we put HTML documentation there, perhaps videos, perhaps diagrams, and maybe we're also sharing content in other mediums like PDF, PowerPoint, Google Slides, etc. All of that information has a habit of going stale very, very quickly. And ultimately, that will impact our ability as consumers to extract value from the API products. We want, of course, to be able to keep that documentation living. And also we want to be able to assert that the interaction with the APIs is working all of the time. So the assertable business value is also a use case that we focused on. So again, imagine if we have a workflow that spans 10 or 15 calls to an API. If one of those endpoints changes, we want to be able to ensure that the overarching value that we're bringing towards the consumer is still achievable, still assertable, and we want to be able to do that prior to deployment. Another use case that we focused on is really looking to reinvigorate the tooling ecosystem around code generation and SDK generation. So again, if we're dealing with very large, unwieldy API descriptions, then if we generate code or SDKs from that, we also will get boilerplate code that is also very large, unwieldy, and bloaty. What if we could generate SDKs specifically targeted at a particular use case and not be distracted by all of the additional bloat that might come in due to the verbosity of the OpenAPI descriptions themselves? We're working also with regulatory bodies and other industry verticals like the OpenID Connect folks and Open Banking UK folks to really look at, can Arazzo documents or descriptions improve the ability for regulators to assert and validate if providers are exposing APIs in a manner and according to a workflow that is expected by consumers. The elephant in the room, of course, is AI. And again, if we want to hand off the responsibility of complex API consumption to AI agents, we want, of course, to ensure that that is achievable in the first invocation as well as every subsequent invocation. We don't have any room for hallucinations with critical API flows. So that's kind of a whirlwind tour through some of the primary use cases that we focused on. But what does the structure of the Arazzo specification look like? Well, if you're familiar with OpenAPI or Async API, hopefully this type of picture is also familiar to you, and it's kind of a 1,000-foot overview of the specification structure. And I'm going to take you through that very, very quickly so that you can feel comfortable and that you can see that the specification itself is nothing scary, and it's a quite simple specification for you to be able to understand and hopefully start utilizing very soon. So the first thing that we have is the info object, and this just houses some metadata about the defined Arazzo document itself. And if we look at what that might look like, here's a little YAML snippet. So at the top, I'm just describing that this YAML snippet is of type Arazzo, and it's conforming to the Arazzo specification 1.0.0. And within the info object, we have a title, we have a summary, we have a description, and then we have the version of this Arazzo document that I am, in fact, creating here. So again, very, very familiar to you if you're comfortable with OpenAPI. Next up, we have the source descriptions. So this is a list of source descriptions. So think of it as other Arazzo workflows or OpenAPI descriptions that can be referenced by one or more workflows described in the current document that we're crafting. So another way to think about these are maybe like imports or namespaces from a programming language perspective, and it sets the boundary for which the workflows that we're describing can be applied over. So we're not allowed to describe a workflow over a remote API if we haven't included it as part of the source descriptions. So again, this will just aid tooling being able to validate that what we're describing in the workflow is actually achievable based on the OpenAPI description of one of the APIs, as an example. So looking at a particular example of this here, I have two source descriptions, one for a pets API located at a particular URL, and that's of type OpenAPI. And again, an adoptions API, giving its URL and also specifying the type of the source description. Next up, we have the workflows, which themselves describe the workflows to be taken across one or more of the APIs to achieve an objective or an outcome. And I'm going to drill into the contents of the sub-objects in more detail, but this is just a high-level overview of a workflow object. So it has an ID, it has a summary, it has a description. It then has inputs. So these are things passed in from the calling context. So these are derived out of band and they're passed in to the workflow. And I'll cover all of these in more detail as we progress. We then have parameters. We have success actions and failure actions. So these are things we can do upon success or upon failure. And when we define them at the workflow level, they are applicable to all steps that are crafted within a particular workflow. We then have the steps themselves. We have some ability to control chaining between workflows via the depends on. And then at the end, a workflow can describe outputs that will be returned to the calling context. And now let's jump into a little bit more detail on these sub-objects. So first up, we have the inputs. And the inputs is a JSON schema object representing the inputs used by this workflow. So in a simple example of that, I have an inputs object here, which defines 4 properties, 3 of which are required. So this is a JSON schema 2020-12 compatible schema. And ultimately, it's just used to describe the shape of the inputs that are required to be passed into the workflow itself. Next up, we have the steps. And the steps themselves are defined via the steps list. And each step itself can represent a call to an API operation or maybe to another workflow. So looking at an example here, we have a step which has a step ID, search pets. It has a description. It then has a mechanism of referencing a particular API operation in this instance. So it's using an operation ID. If the open API description or operation that we're referencing doesn't define an operation ID, we have another mechanism called operation path, which we can specify the pointer location of the operation in the open API description that we're targeting. If we were referencing a workflow, we would specify a workflow ID rather than an operation ID. Then each step will have parameters, which I'll get into in a couple of moments. It then has success criteria. So these are the criteria that will determine if this particular step is successful. So in this instance, there are 2 defined. So if the status code returned by the getPets operation is 200, and also if I receive back a response body and it contains pets with more than 1 pet described, then I can determine that this particular step is successful. Optionally, I can do things on success or on failure. And for each step, I can also specify outputs that will be available to subsequent steps within the workflow, and or we can map them to outputs defined at the workflow level. So then jumping into the parameters. So parameters is a list of parameter objects, and each representing parameters that we can pass into a particular API operation that we're targeting, or indeed to another workflow. So looking at a very simple example here, we have 4 parameters, and we are mapping these into a particular API operation, and we're describing how that mapping mechanism should work. So we're specifying that they will map into a query parameter that is defined. So if we look at the name category here, so we're expecting a category query parameter to be defined on the API operation. And for the value that is expressed here as a dynamic runtime expression, that will be evaluated by the tooling, and the actual value will be sent into the query parameter on the API operation. And the same similar approach follows suit for the other parameters that are defined here. We then have moving on to the failure actions. So these are optional things that we can do upon a failure of a particular step. Looking at an example of this, here we have a retry failure action. So there's different types of failure actions that are supported. One is, of course, retry, and retry allows us also to specify a retry after and a retry limit. So what this means is we should retry the current step after 1 second, and we should exhaust the number of retries if we try to retry this 5 times. Now, how do we know to execute this particular failure action? Well, that's all specified by the criteria. So if the criteria holds true, then it means we can execute this particular failure action. So in this case, if the status code returned by the API operation is 503, then this particular optional retry step becomes applicable. We also could call out to other steps or other workflows as part of the retry mechanism. So thinking of a very common example, if we had criteria describing a situation where status code 401 is returned by an API operation, if we inspect the authentication token and we determine that it is expired, we could call out to a refresh token workflow, and then the calling context will come back once we have that refreshed token, and then we could use that refreshed token to retry the current step. The other types of failure actions that we have are end. So that's pretty self-explanatory. If the criteria defined hold true, then the workflow should end at that point in time. And then we also have a go-to type failure action. And this is a one-way transfer of workflow control to a specified label. So that could be another workflow ID or step ID within the current workflow itself. Similarly to the failure actions, we also have success actions. Again, these specify what to do upon step success if we determine that we want to define these types of things. So in this particular example, it is a go-to type success action. So the types of success actions are slightly less verbose than for the failure actions. So currently we just support go to and end from a success action perspective. So in this particular example, if we get a response body back that contains at least one pet, then we can go to the join waiting list step. So that gives us an ability to potentially skip some sequential steps if we determine we already have enough information to go to a step that might be defined later in the workflow and speed up the execution time. We then have outputs. So this is just a friendly map between a name and a dynamic output value for any given step. Looking at a very simple example of this here, we have a pet ID. And again, we have a runtime expression, which will contain the ID of the pet to be made available to subsequent steps. And then once all steps are defined, we then also have outputs that are at the workflow level. And again, very similar construct, a map between a friendly name and a dynamic output value. And this will be made available outside of the context of the workflow. So back to maybe the calling client that is invoking or running the particular workflow itself. So in this particular example, we have 3 output keys, each with a value defined as a runtime expression. And then, of course, we have reusable aspects within the specification itself. So we have components and we have other objects that all help us to reduce the amount of verbosity needed to craft an Arazzo document, and allows us to reuse different components and different objects across multiple steps or workflows. So let's take a look at a little example of what this could look like. So let's imagine that we're working for a free debt student bank, and the problem that we're trying to solve is that all of the retailers that are out there supporting students in our local universities are preparing for the rush. So all of the students are heading back to university. They need to source the appropriate equipment, such as laptops and software, and ultimately do so without incurring yet more student debt. So the solution that we see is that we're going to try to ease that by making a buy now, pay later product available for the retailers. And we will offer a 0% loan rate towards those students based on products that we determine fitting the needs and warrants that they will have as they start their new academic year. So the example workflow that we would want to make available to the developers of the different retailers that are partnering with us to embed this capability into their e-commerce type platforms would incur the following types of steps. So we would want to be able to check and verify that the selected products in the particular basket are indeed eligible for a buy now, pay later flow. We then want to retrieve the terms and conditions and determine the customer eligibility. If we don't know who the customer is within our banking backend systems, then we would need to create the customer record. If all of the checks and balances up to that point go well, then we would want to initiate the buy now, pay later loan transaction. And then we would need to be able to authenticate with the customer, obtain their authorization for the loan. And then we would run a calculation, retrieve the payment plan, and be able to render that back to the user within the actual e-commerce platform that they've initiated the process through, and ultimately giving the developers on that retail side the ability to update the order status and fulfill the actual order and send the equipment out towards the end user. Now, the APIs that we might have on our banking side to make this available could easily be split across multiple teams. So in this hypothetical example, we have 2 APIs, an eligibility API with various endpoints in it, and a loan API with various endpoints in it. And what we want to make available is not just directly these 2 APIs with lots of manual documentation for the retail developers, but we actually want to make available the workflow exactly that they need to implement in order to make this capability available. So we can craft that using the Arazzo specification. And the main point that we're getting to is that, yes, we can make the YAML available, but the YAML in and of itself is not going to make the experience for that consuming developer much better. What will make it better is the tooling that will be built up on top of the Arazzo specification will bring a lot more affordances and value towards the integration experience on the consuming developer side. And we can easily imagine that instead of the end developer on the retail side having to parse and process this YAML manually, that they will get different representations that will make it much more understandable as to in what sequence they need to make the API calls in order to embed the capability. So we can imagine very, very easily that we will have enhanced rendering, which will act as living documentation to guide a consuming developer through the various steps. Now, I also have a little GPT that I'm making available to really help people start getting familiar and interacting with the Arazzo specification. So if we were to look at this sample GPT, I can test it on its Arazzo knowledge. So I ask it to give me some benefits for the Arazzo specification. As you can imagine, these types of tools are pretty good at generating text. More importantly, I can give it access to the two APIs, and I can ask it to create an Arazzo document based on the workflow steps that I outlined in the previous couple of slides. And what it does is a pretty good job. So 80 to 90% accurate Arazzo document generation. I then fix that up and I ask it to generate some documentation that I can immediately embed into a developer portal, including some of the diagrammatic rendering outputs that can make it much, much easier for a human developer to understand. And what that means is I can then embed that within my developer portal. So this is an example of Swagger Hub developer portal, where I have the eligibility API and the loan API. But through the Arazzo specification, I was able to create very real feeling, let's say, getting started guide. So I can highlight exactly the steps for the consuming developer, what inputs they need, what outputs they should be interested in. I can render the different plant UML or mermaid diagrams. And I can also give some code snippets that actually match the expected use case. So if there are other endpoints in the APIs that we're not interested in, and the consuming developer is never going to see them, they will be just kept in focus of achieving their job to be done, which is integrating this buy now, pay later capability into their offerings. Now, the tooling ecosystem is still emerging around the Arazzo specification. So we formally launched the specification over the summer, but already we're seeing vendors that are adding support. So we are seeing LibLab have launched some SDK generation support. Redocly have added some linting capabilities through the Redocly CLI, and they also have published a roadmap on future Arazzo support. APImatic have just launched their Arazzo support within their guided walkthroughs capability for their SDK generation. Speakeasy are working on some testing tooling as well. And the question that always comes to me as well, what are we doing on the Smartbear and Stoplight side? So what I'm delighted to say is that we have just launched spectral support for Arazzo, so allowing you to govern your APIs like you're familiar with from an Open API and Async API perspective via Spectral. You can now do also the same for your Arazzo documents. And it's just as easy as adding extends Spectral Arazzo to your rule set file. So really just to prove that out to you, let me just jump over very quickly to Visual Studio Code. This is my Spectral rule set that I have just extended with spectral.arazzo. So this means if I give it a file with Arazzo contained within it, it will apply an opinionated rule set against that to determine if the Arazzo document itself is valid. And I can try that immediately through a call to the CLI. So first up, let me just showcase the test that I would have ran against the Arazzo document that was generated by the GPT in a previous step that I would have shown with the little video. So I would have taken the output from that GPT, I would have saved it locally, and then I would lint it with Spectral. And that would have pointed out that there were a few issues in the auto-generated Arazzo document itself that allows me then to fix them up and then get a valid Arazzo document that I then fed back to the GPT to create the more living documentation. And you can imagine in a more deterministic setup, you could do all of this through your CI/CD pipelines. I also have been able to find and locate some issues within the example Arazzo documents that we have within our GitHub repository as part of the working group on the specification. So very, very useful to be able to do this in an automated fashion, which will beat kind of the human reviews every single time for these kind of nitty-gritty types of details. So when I ran some checks against the examples, let's see what comes out. So looking at the FAPI Arazzo document, you can see this is pretty good. It is giving me an opinionated hint that I should add in some summary information. Let's try another one. Try the OAuth one. Again, this is giving me a warning and a hint that I could be doing a little bit better. And we won't try that one. We'll try this pet coupons one. And this actually found some errors. So some runtime expressions that were not valid. So this then allowed me to issue a PR against the repository to improve the actual examples in our OpenAPI Arazzo specification repository. And because it's, of course, very important that we have those as accurate as possible. So if you want to learn more and if you want to know how to get started with the Arazzo documentation, I would say you can immediately start crafting some Arazzo documents. You can link those with Spectral or with some of the other tools that I covered very, very briefly. If you want to get involved with the community, you can join the Slack workspace for the OpenAPI, and there's a dedicated channel for Arazzo that you can also join. I would encourage you to start the repository. And please do submit any use cases that you have, because we want to validate them as a working group. So thank you very much, everyone.